Welcome to MBA 617 decision modeling with spreadsheets. That could be just as easily decision making. I'm your instructor, Bill Foote, and this is week one. And in week one, we're going to do what I call spreadsheet engineering part one. Next week, we will do part two. And the activities for this week will include reading and reading, but more importantly, actively working with the reading, working with a model that's already been built in Excel. Our platform is Excel. And what I would like to do right now is simply walk through the primary reading for this week, which is contained in an HTML file on Moodle. So I'm going to open that file. It's also a file that is located on the course Google Drive under Readings. See, there's quite a few things to choose from here. On Moodle itself, let me share my screen so you can see what I see right now. We have resources to help us along the way. Our job this week is basically to make this diagram happen to help somebody make a pricing decision. I've invented a restaurateur and cuisine entrepreneur. Her name is Simone Tortier. She makes vegan pies. I'm vegan, so I'm interested in this all automatically, but it's across different cultures. And a pie to her right now is dough. Next week, she's going to widen her horizons and think of vegetable wraps, all sorts of different ways of wrapping a filling. So horizon development and entrepreneurship go hand in hand here. She has a simple feed the hungry mission, and she's trying to find the right price given customer willingness to pay and the fact that she has suppliers and costs and contracts, as well as the cost structure of her own organization, which we're just going to lump sum into fixed costs. But she's very, very concerned about how events can change and affect her decision. So she wants to see how sensitive her pricing decision is relative to possibly high carrying costs all over the place. That's her main issue, and we're going to help her by devising a project. We're going to introduce one another all around. We're going to figure out how to help her. And this course is an example of basically a project that could be used anywhere to help a decision maker, to support a decision maker in a decision. But we only have one decision to make here, and that's just pricing. In future weeks, we will see multiple ways of making a decision subject to multiple constraints and maybe even multiple objectives in the decision-making process. So we're going to, first of all, map the decision problem. We'll see that in a minute. And ultimately, we hope to live to tell the tale, to communicate what we're trying to do to the decision maker and give her a tool, a palpable tool to support her. That's the product. We have resources at our fingertips. Yes, these are the primary resources for what we're going to do here. This first one, Raffensperger, is a very long resource, over 75 pages. But yes, it's like a book. And it's like the Winston book that is in the syllabus. Everybody should have a copy of the Winston book. When I do Excel, I've got the book at hand all the time. Please use it. Please read it. More importantly, work the examples in it. And we're going to need to do that this week. Here is the week one. Make a Pie is the name of our company right now. We might have somebody try to change that, but right now it's pretty useful. And it's a weekly profit model this week. Next week, we're going to consider other issues because other things are going to happen to Simone Tortier's company. And very interesting things, very good things. Can she take advantage of those things? And again, achieve her mission goals. But the main reading is right here, week one, Spreadsheet Engineering. It has several pieces to it. It's an HTML file written in R, by the way, that allows us, I call this tortuous pie making in the sky. Let's see if I can move this out of here a little bit. There we go. And I just want to run through this. Please realize that if I see a mistake or error in here, it will get fixed. Please let all of us know that there is a mistake or error or an issue. Put that up on the wall. I give a short view on why we do spreadsheets. Spreadsheets to me are some of the most dangerous tools we have. They're very volatile, they're very dynamic, but they're incredibly useful. One of the most important uses in my professional work has been to prototype ideas, make models, make simulations, run stuff over and over and over again with different assumptions. This was hard to do a while back unless you were well versed in a programming language and you were really part of a small cadre of people who could do that. And the language when I was growing up, and this was Fortran. They used Fortran to shoot missiles in the sky and aim them at the moon, and hopefully they came back. VisiCalc is the spreadsheet program that basically made the Macintosh, which was that little box of a computer sold by Apple in 1985. I had one. It was remarkable what it could do because it was the first Windows-based operating system. Microsoft came out with the next one and also invented Excel at the same time to go along with it and integrate it with Word and other products like Access, the database. But please read this. It's a very interesting set of ideas. George Gilder, the prognosticator of all times, basically says we should waste transistors. Now, this is a trope, a figure of speech that I call ironic hyperbole. It's very exaggerated, and it means something different than what it says. Of course, we're not wasting anything. So no more than we're wasting brain cells when we think. We actually grow brain cells when we think, and think in very uncomfortable areas as well, as much stress as that might be. Michael Schrage, about 20 years ago, came up with the idea of wasting simulations, wasting prototypes. We should always be working on the next prototype, the next working model. Tear it down, build it back up, see what it really can do, stretch it all over the place, break it. And then we'll know what we don't yet know, the known unknown and the unknown unknown. Very important in development of anything. Ideas, products, services, economies. VisiCalc was built in 1981, and it basically made the Apple IIe and the Mac. It was taken over by Lotus. Lotus didn't move quickly enough into a Windows-based environment. Microsoft wiped them out. Microsoft's first big commercial customer was the accounting firm Ernst & Young in the mid-90s. Now, they got rid of all of the Apple products at that time, went back to, IBM PCs, PCs in general. We had Michael Dell by that time. But you can see how things develop. It is a rapid prototyping canvas, scratch sheet, board off of which you could put all sorts of things on it and do them quickly and cheaply. 20 days of work into 15 minutes. There we go. That was the big take on that. Please read that. Very interesting. But more importantly, I say let's play. Some question to keep in mind about what we're talking about as a business, what we use spreadsheets for in general. What's a decision? Actually, decision is a result of a judgment. You know you should do something and you go ahead and do it, but it takes will, political will, moral will, whatever you want to call it, emotional commitment. Then you sign the check and you're going to go ahead and do it because you've made a commitment. There are different types of decisions. Prudential decisions always give you an exit. Okay, it's not a hard, it's a hard commitment, but you have a way out as well. And what's a model? Model is absolutely not reality. I highlight that because when we know something, it's not just taking a look at something, it's thinking about it and then interpreting what we see. So keep these things in mind. It's not a philosophy course, so we're not going to go in that direction, although that would be a great discussion. And that discussion is had in a number of places. Now, those are questions. Please read through and maybe visit the European Spreadsheets Risk Interest Group. There's quite a few interesting recent problems with spreadsheets. Exactly these same problems can occur in any software development environment. And the core problem isn't so much the spreadsheet, although it is prone naturally, operationally to error, just a selection, copy and paste problems that have occurred. It's because none of this was controlled or governed. No good data or model stewardship was applied. That's the reason. People were pressured and did something that was stupid. Errors, ignorance, errors and omissions. Very good examples to look at. And there are many more than these. On the later side, look at how Dilbert looked at this whole business. And this was in the 90s. We were already going through the cultural differences about this. But we really need to learn from errors and get to the prevailing recommended practices. There's some great work done about 10 years ago at Lloyd's Bank when it became the Royal Bank of Scotland. Susan Allen. I was involved in a massive piece of work at British Petroleum, BP at the time, because they were merging with Amoco, the U.S. Oil company, and we had to merge their international trading operations, which is kind of like the broker in between upstream development and downstream usage of product. BP also created an emissions trading program. Sir John Brown, their CEO, was adamant that they become greener because everybody could see where everything was going with fossil fuel. It has been known for a very long time, the contribution of fossil fuel to planetary and personal health. How to document spreadsheets, guidelines. Raffensperger, I give you Raffensperger. These are easy things to read, hard things to implement, but always something to reflect on. IBM, the IBM spreadsheet modeling design practices from the Wayback Machine, 1990, 1999, 21 years ago. Actually, that's when I probably should have given you the Raffensperger, but they're all very good. And here's a starter's list for things you should never do. Never hard code data in a formula, ever. You will do it. you'll write a mortgage payment thing and put the 5 in for 5 years, and then all of a sudden your contract changes. It's a 6-year contract, and so the 5 hard coded gets lost because you never documented it. They never take the word spread in spreadsheet literally. People will take a spreadsheet and make calculations across things you can never see. They're out. If you look at a spreadsheet, there are a million rows, and a lot. There's supposed to be 512. I never counted them. I will someday. 512 columns. What kind of a table is that? And any table is just a rows and columns with headers and indexes. That's a table from database. Never guess at the length. Never guess at anything. Okay, never guess at the length of the dimensions of any array, and everything in a spreadsheet's an array. And you're going to see examples of that in your own work. In my work, I make these stupid mistakes all the time. If then else is the way we control the logic of all processes in computing and in life. If this, fine. If this condition's true, then do this. Otherwise, do that. Okay, that's an if then else. We use it all the time. But the notion of a nested if then else, and we should probably try to come up with examples of what those are. The sixth thing is a really important thing to me because it's a waste of time, and a lot of errors are made. When we make presentations of our work, we want it consumable by the person who desires to work, in our case, Simone Tortzier. So we're going to show a graph, we're going to show a table. Thou shalt not calculate anything in a graph or a table. Well, I do, and I'm going to change it. I'm going to engineer it back out in one instance. I make a slide bar and actually do a calculation in a table, in a presentation. Oh my gosh, no, we fix those. We identify them and we adjust. Okay? No pointing the finger. Don't need to do that. We do need to solve a problem. You can see that. I'd like to see how you would solve that problem. I have a setup set of modules that you can look at to do that. I do not recommend that anybody use Excel as a standard system of record database for legal or other purposes, but it's done all the time. Part of the problem is it's portable. The database can walk. Your system of record can walk away from you. Not a good thing when you're relying upon it for disclosures to your investors or your regulators or yourself, management information systems. And don't ever pretend you don't know what a named range is. If you don't know what it is, look it up immediately so you can never violate 8. All right, named ranges are our savior in everything. We name variables in all programming languages for this reason. We don't want arrays of information to be confusing to the instructions we're giving to our modeling robots. These are just robots. That's all they are. They have no innate intelligence. Any so-called intelligence is the programming we put into them. Okay, pretty important point. And here are some things to practice. Please read through these. Don't worry about the indirect function yet. We'll worry about that next week or the week after. Test your model all the time, but always start your work with a paper and pencil process. So here we have Pie in the Sky, wonderful series, British series, and of course it's about cooking. We have a bunch of questions that we're being confronted with by our client. Gluten-free, vegan, full of micronutrients. That's good for my heart, by the way. Yours too, perhaps. No dairy. No dairy's for small children. But boy, every now and then, just a little pinch of Parmesan or feta. Oof, amazing. Okay. Make a Pie captures value in its marketplace by basically taking two basic ingredients and making them into something that people want to buy. Right now, they're selling to local grocery stores. They should also be selling to restaurants. They should be selling to homeless shelters. They should be selling to schools. And major competitor to them would be something like Tyson's, sell to prisons. They have both school and prison populations. Processing. Here's processing cost. This is actually how you make this stuff. Number of pies. Notice in thousands. So that's going to catch us later on. And the actual cost. Okay, somebody collected this data. Simone likes to collect data because she's an entrepreneur. She wants to track her progress and look at the business questions that are raised. This is how you start all these projects. You get to what's important to you. What is it you want to get at the end? And then other questions come up. If her metric is profit, let's define profit. And then what are its determinants in that definition? What is the relationship here between output volume and this particular expense, processing expense? It's how you make something's production. It's the operation itself. It's the lights, the camera, the action of the whole thing. The fees you got to pay. Maybe that's going to be in fixed costs. That's what the accountants will deal with. Whatever the level of activity, there's going to be costs that will be incurred anyways. Demand. They played with demand. Could they play with demand some more? Could they hire a survey? Could you see a survey monkey or something, or facilitator or something like that? To they have bounce back cards. Do they? I mean, what do they do? Okay, that's a marketing problem. What is the average relationship in this case between price and revenue? How sensitive is revenue to changes in price, changes in volume? Those are called elasticities from economics. They're very practical. Price. So what price maximizes profit? That's what she really wants. What price will make a pie even break even? And now, if you remember economics and profit curves, there's going to be two break evens. Look at that one. Tortilla muses further. This will be next week's problem, multi-period value across a 3-year horizon. What if her business is worth $2.5 million today? I don't know if that's right. We'll check that out later on. Here's the paper and pencil. You have total profit determined by total revenue and total cost. Total cost is determined by total processing cost and total material cost, and a third thing, fixed cost. Total material cost is determined by how much material you need to meet demand. Aha. And filling and dough. There's also a unit processing cost associated with total processing. Also demand. Demand's in the middle. How is demand? This is a demand-driven decision. Where's the decision? Pie price. Price per pie. It affects revenue directly. It affects demand. Demand determines revenue, so both and. Demand also determines both total processing cost and material cost. It's at the center of every supply chain. Supply chains are usually thought of as very linear, with demand at the end, supply and planning at the beginning. I think it's more like this. Okay, I think this is a little bit more useful. This is called an influence diagram. From this, you can build so-called decision trees. There's a whole mathematical based science of this. It's actually called a directed acyclic graph. It's causal relationships. And we're going to use maps like this to help us understand how to build models. We'll go through it. So the first stop, we agree with Madame Tortzier, she's Quebecois, by the way, that cost and volume are the first thing we want to, she wants to get a handle on this right away. So here is a chart that is made in Excel. There's a little note here. Note for C. Winston, chapter 54, charting tricks. So this is where you go. You click on that end note. You immediately pick up Winston, chapter 54. There's like 100 chapters in this book, 90 some odd chapters in this book. It's grown over the years. I've been using it for years. Charlie Kidd was the guy who really put the books together. Chapter 54. Charting tricks. And there's also a thing called estimating straight line relationships. We're using a quadratic. There's lots of different charts in here. Sunburst charts, tornado charts, country charts. I mean, it's all here. How do you do the famous insert a vertical line, draw a line? We're going to be doing that as well. The tables in, it's all here. So this is something that you should look at. And when you look at something like that, okay, this is a course. What do you do this week? You pick out a couple of these and try them out. They're very easy to do. And when you buy the book, you also buy the spreadsheets that come with the book. That's the most valuable thing. It's all reusable. So let me go back. There's a bunch of other things here you could read. Yeah, okay, fine. What you do is you just when you make the graph, and I'll probably have a graphing session that we can go through to see how to do this raw and make it happen. If you right click on one of these, a add trend line occurs. You can add all sorts of things that way. Here is the thing. Now notice that all of these pictures are going to start with row A, row 1, column A. Here's the data that's here. Here is the generation of the coefficients of this equation, this quadratic equation. It's very annoying the way this line est works, and line est is a array function. Oh, and also there's other things that we need to look at. What is this one? 6. Oh yeah, 5 and 6 index match. Array functions and formulas in chapter 91, line est at page 578. I hope that's right. And it's also discussed here in this awesome online resource, which is, I use this all the time. Mike Barker, I think, at MIT for years has put this together, and he's got a little thing here. We can go back to the different array functions, how to use them. They're very, very useful in Excel. Very useful. Let's see if I can find my way back here. There we go. And with some tricks of the trade. Chapter 59 for multiple regression in chapters 4 and 5. I would start at chapters 4 and 5. Get yourself used to the idea of how to look things up and plot them somewhere else. Okay, look something up from an odd table and put it into a table that doesn't look like anything like the previous table. From the source to the destination. Index match is used widely, but what's more used is something called VLOOKUP and HLOOKUP, which are just not up to the task of index match as the jack of all trades. It's probably the most, if you go to an associate's program at a hedge fund or Goldman or some large bank, for example, or I was working with people at Eli Lilly in their decision department, or Morgan Stanley. They use this. One of the big questions is, do you know how to use index match? No. Okay, fine. Well, we have some other work you can do. You want to be the one who knows index match, definitely. And I can't emphasize that enough. So this is how it works. But then we can actually put together predicted costs using the sum product. And we'll show you how that works in a separate video. Demand analysis here. Notice the formatting. I don't know where this stray 4,000 came from. I'm going to get rid of it in the next iteration. It probably should also have a title. This is yet another worksheet. You have a workbook, and it's made of little tabs at the bottom called worksheets. It's all over the place. There's an intercept and a slope, which is just rise over run. Look at the formulas. I have formulas everywhere for you. Suss them out. What does this ampersand do? Well, you will find out. I'll give you, it's called concatenate. You're putting strings of text together. Oh, and there's all sorts of interesting chapters on text manipulation. So I'm generating a demand curve here. Oh, I think I'm going to show the, I also have a picture of it. I'll put that in the next iteration here. Because why use a table when you can visualize it in the graph, right? Here's the weekly profit model, a separate worksheet with all of the things. So your job is to go into this worksheet and see how this number comes from some other place, some other worksheet, and why would you want to do that? Okay, nothing is hard-coded in here at all. Notice that. Nothing is hard-coded. This is a calculation machine. That's why. We want to keep it that way. We want to have data integrity for the calculation machine, and we will enforce that. And part of the enforcing is documenting it. See, oh, sensitivity. I would be going now to the sensitivity sheet. Where did that come from? Okay, and then here's profit sensitivity. This is the major question to be asked and answered. Notice we have a profit, we have a break even somewhere between $6 and $7, but we also have another break even between $10 and $12. Classic economics. The classic economics comes from this kind of basic consideration. We generate a grid over here with grid values generating the pie price grid from 3 to 12. We could change this. We could zoom it in, zoom it out. We could do all sorts of things with this using slide bars, for example. There are 9 nodes. That's how we talk about grids as a graph. 1, 2, 3, 4, 9 nodes. But notice the formula. We take the node F7 minus 1, but 8 intervals, 8 jumps, because we start with the minimum. There we go, that's F6. Start with the minimum and add F8, the width of each of those node intervals. It's like cutting up a piece of board into equal pieces. And then we do something called a data table. Oh, very complicated. Okay, the what if data table. And of course, there's a reference. I call it a vast topic, chapter 17. You should be immediately going to that and trying it out. One of the problems with it, every time you change a cell anywhere, even in other spreadsheets you might have open, it's going to recalculate everything in that data table. The data table is small like this one, it's no problem. But if it has 10,000 rows in it, it's a problem, which means you can't edit anything. So Excel, of course, has a way to control calculations, whether the sheet calculates or not. And I'm not a big fan of it, but I do use it because, again, it's a rapid prototyping device. And I will put one then down here, the picture, but it's coming up. I have a separate place where I assemble the data needed for a plot. I have a title, y-axis, x-axis, and each one of these, I'll probably modify this to show you where I got these from. These actually come from data somewhere else. And I could also scrap it together with other things. Profit is probably from, yep, it'll be from here, in the other worksheet. Everything communicates with everything else. And lo and behold, here is the model. We have slide bars up here. What does that say? Yeah, they're called user form controls. And they're located on the developer ribbon. And if you don't have a developer ribbon, here's where you go to put it on. It'll tell you how. Okay, always go to the people who made the application, in this case, Microsoft's Excel engineers. Okay, and this is helpful. This is the profit curve in blue. Here's a vertical line showing the maximum profit, which was communicated to the graph from this. Here's the maximum profit. It'll be the max of this profit array starting below the blue here and going up from that negative to that negative. And the price is at the right row. It's this price right here. It's at this row. Let's see, we have row 1, 2, 3, 5, 6, 7. Row 7, find in the price array, row 7. That's what index match does. Match says what row is a maximum price, is a maximum profit in? Row 7. Okay, index says in this array, go to row 7 and report the value. That's all it does. The lookup, powerful. Okay, and then we create X and Y values. These are, you got to remember coordinate geometry here. Stuff is all driven by coordinate geometry. And this whole table here, which is, I will comment there's too much in it, comes from somewhere else. But except for these slide bars, I actually do a calculation with filling costs per pi, dough cost per pi, and fixed costs. I got to fix that because it violates a fundamental principle of software engineering. Modularize everything. Everything has its purpose. Don't mix other modules' purposes with the purpose of this module, which is just to display things and have an interaction. This interaction is perfect. But there are two values underneath here. One is there's a start value for the cost, and then there's an increment value, which is caused by moving the slide bar back and forth. I need to put those somewhere else. And in the next video, I'll show you how I do that. I'm going to put it in this plot setup piece. It's going to be renamed setup. And down here, you can see all of the modules of this model. There's a dashboard, questions. That's really project scope, an influence diagram. You've seen all these pictures. Even data is separated. And the only data we really have right now are perhaps assumptions. I'm going to fix that. Perhaps the cost, expenses, fix that. You have a cost analysis, a demand analysis, a profit analysis, calculations all the way through here. Then you have sensitivity. And finally, you have the setup for all of the presentation. We call this in databases, Oracle and Microsoft Server enterprise databases. We call this the presentation layer. And we're using exactly the same principles here. There are references and endnotes. this is a book you need to have. It's available for, I don't know, 30, 40 bucks probably, but it's a professional reference that you can use, and it comes with software. Okay, you have to go online to get it. And I think that will be it for the moment. Stop the share. And that is a typical walkthrough of the reading. Now go ahead and do the reading. Bring up the worksheet. I will produce another video for you to look at for that worksheet and actually play with it a little bit, as you will do too, okay? That'll be your big assignment this week. Try to reverse engineer that spreadsheet, but more importantly, go and learn what a sum product is. Go and learn what line est does for us. Go and learn what a data table does for us. Now, you're not going to get it all at once. No way. Nobody does. You only get it by practicing this and doing this for way too long in different systems. So I've got a little bit of a perspective, but I still make big mistakes. I'm still stupid about certain things. I'm not saying you will be, but don't kick yourself. Okay, if you run into a brick wall, go to the wall, the course wall, and say, I have no idea how to do this. The course wall is crowdsourcing a solution. That's what you should do. That's what you should do. Also, there's a discussion board in this week, and every week it'll probably run like this, where it's read and reflect. I'm going to fill what we just did in right here, their activities for the walkthrough. Then read and reflect and post something I'm asking you to do here. Post on this discussion. I will also ask you here to do at least index match or line est or something. Here is where this next activity here will be what the case is next week. Now, you don't have a case to hand in this week. Okay, you have to go through and re-engineer this model, go back and forth and share ideas, and do it in teams. More importantly, do it in teams, whatever that team is. So let me share my screen one more time to show you the rest of the Moodle. And I'll leave you alone. Here's the read and reflect I was just talking about. I'm going to put up here a video. And down here normally will occur a case every other week. So you don't have to hand anything in except for these discussion boards, okay, and have these discussions each week. You got enough to do. And again, as I say, do it in teams. Okay, that'll be it. That's a lot of walkthrough. I expect that each week to some extent, and expect another video just on the model itself. Okay, I'll see you then. And again, thank you very much for your very kind attention, and holler if you need anything. Take care.